Warm greetings from TNV Academy. Today in this session, we will discuss about big data and its related concepts. However, what all topics we will discuss in this session are as follows. What is big data? Characteristics of big data, types of big data, importance of big data, how big data works, and applications of big data. So let's start our discussion and talk what is big data. Big data is primarily refers to data sets that are too large or complex to be dealt with by traditional data processing application software. Data with many entries offer greater statistical power, while data with higher complexity may lead to a higher false discovery rate. Though used sometimes loosely partly because of lack of formal definition, the interpretation that seems to best describe big data is one associated with large body of information that we could not comprehend when used only in similar amounts. Big data usually includes data sets with sizes beyond the ability of commonly used software tools to capture, accurate, manage, and process data within a tolerable elapsed time. Big data philosophy encompasses unstructured, semi-structured, and structured data. However, the main focus is on unstructured data. Big data size is a constantly moving target as of 2012, ranging from a few dozen terabytes to many zettabytes of data. Big data requires a set of techniques and technologies with one forms of integration to reveal insights from data sets that are diverse, complex, and of massive scale. Let us now move forward and discuss about the various characteristics of big data. The big data can be described by the following characteristics. The first one is volume. The quantity of generated and stored data. The size of the data determines the value and potential insight and whether it can be considered big data or not. The size of the big data is usually larger than terabytes and petabytes. The second one is variety. The type and nature of the data. The earlier technologies like RDBMS were capable to handle structured data efficiently and effectively. However, the change in type and nature from structured to semi-structured or unstructured challenge the existing tools and technologies. The big data technologies evolved with the prime intention to capture, store, and process the semi-structured and unstructured data generated with high speed and huge in size. Later, these tools and technologies were explored and used for handling structured data also, but preferable for storage. Eventually, the processing of structured data was still kept as optional, either using big data or traditional RDBMS. This helps in analyzing data towards effective uses of hidden insights exposed from the data collected via social media, log files, sensors, etc. Big data draws from text, images, audio, video, plus it completes missing pieces through data fusion. The third one is velocity. The speed at which the data is generated and processed to meet the demands and challenges that lie the path of growth and development. Big data is often available in real time. Compared to small data, big data is produced more continually. Two kinds of velocity related to big data are the frequency of generation and the frequency of handling, recording, and publishing. The fourth one is veracity. The truthfulness of reliability of the data, which refers to the data quality and data value. Big data must not only be large in size, but also must be reliable in order to achieve value in the analysis of it. The data quality of captured data can vary greatly, affecting an accurate analysis. The fifth one is value. The worth in information that can be achieved by processing and analysis of large data sets. Value also can be measured by an assessment of the other qualities of big data. Value may also represent the profitability of information that is retrieved from the analysis of big data. The sixth one is variability. The characteristics of the changing formats, structure, or sources of big data. Big data can include structured, unstructured, or combinations of structured and unstructured data. Big data analysis may integrate raw data from multiple sources. The processing of raw data may also involve transformations of unstructured data to structured data. So we will now go on and discuss about the various types of big data. Following are the types of big data. The first one is structured. Any data that can be stored, accessed and processed in the form of fixed format is termed as structured data. Over the period of time, talent in computer science have achieved greater success in developing techniques for working with such kind of data, where the format is well known in advance, and also deriving value out of it. However, nowadays we are foreseeing issues when a size of such data grows to a huge extent. Typical sizes are being in the large of multiple zettabytes. The second one is unstructured. Any data with unknown form or destructured is classified as unstructured data. In addition to the size being huge, unstructured data possesses multiple challenges in terms of its processing for deriving value out of it. A typical example of unstructured data is a heterogeneous data source containing a combination of simple text files, images, videos, etc. Nowadays, organizations have wealth of data available with them, but unfortunately, they don't know how to derive value out of it since this data is in its raw, from or unstructured formats. The third one is semi-structured. Semi-structured data can contain both the forms of data. We can see semi-structured data as structured in form, but it is actually not defined with example, a table definition in the relational DBMS. Examples of semi-structured data is a data represented in an XML file. So we will now move forward and discuss about the importance of big data. The importance of big data doesn't simply revolve around how much data you have. The value lies in how you use it. When you combine big data with high-performance analytics, you can accomplish business-related tasks such as determining root causes of failures, issues and defects in near real time, spotting anomalies faster and more accurately than the human eye, improving patient outcomes by rapidly converting medical image data into insights, recalculating entire risk portfolios in minutes, sharpening deep learning models' ability to accurately classify and react to changing variables, detecting fraudulent behavior before it affects your organization. So let us now understand how big data works. Big data gives you new insights that open up new opportunities and business models. Getting started involves three key actions. The first one is integrate. Big data brings together data from many disparate sources and applications. Traditional data integration mechanisms such as extract, transform, and load (ETL) generally are not up to the task. It requires new strategies and technologies to analyze big data sets and terabytes or even petabytes scale. Duration integration, you need to bring in the data, process it, and make sure it's formatted and available in form that your business analytics can get started with. The second one is manage. Big data requires storage. Your storage solution can be in the cloud or premises or both. You can store your data in any form you want and bring your desired processing requirements and necessary process engines to those data sets on a demand basis. Many people choose their storage solution according to where their data is currently residing. The cloud is gradually gaining popularity because it supports your current compute requirements and enables you to spin up sources as needed. The third one is analyze. Your investment in big data pays off when you analyze and act on your data. Get new clarity with a visual analysis of your varied data sets. Explore the data further to make new discoveries. Share your findings with others. Build data models with machine learning and artificial intelligence. Put your data to work. So let us now move forward and discuss about the applications of big data. Big data can help you address a range of business activities from customer experience to analytics. Here are just a few. The first one is product development. Companies like Netflix and Procter & Gamble use big data to anticipate customer demand. They build predictive models for new products and services by classifying key attributes of past and current products or services and modeling the relationship between those attributes and the commercial success of the offerings. In addition, uses data and analytics from focus groups, social media, test markets, and early store rollouts to plan, produce, and launch new products. The second one is predictive maintenance. Factors that can predict mechanical failures may be deeply buried in structured data, such as the year, make, and model of equipment, as well as an unstructured data that covers millions of log entries, sensors data, error messages, and engine temperature. By analyzing these indications of potential issues before the problems happen, organizations can deploy maintenance more cost effectively and maximize parts and equipment's uptime. The third one is customer experience. The race for customers is on. A clearer view of customer experience is more possible now than ever before. Big data enables you to gather data from social media, websites, call logs, and other sources to improve the interaction experience and maximize the value delivered. Start delivering personalized efforts, reduce customer churn, and handle issues proactively. The fourth one is fraud and compliance. When it comes to security, it's just not a few rogue hackers. You are up to against entire expert teams. Security landscapes and compliance requirements are constantly evolving. Big data helps you identify patterns in data that indicate fraud and aggregate large volumes of information to make regulatory reporting much faster. The fifth one is machine learning. Machine learning is a hot topic right now. And data, specifically big data, is one of the reasons why we are now able to teach machines instead of program them. The availability of big data to train machine learning models make that possible. The sixth one is operational efficiency. Operational efficiency may not always make the news, but it's an era which big data is having the most impact. With big data, you can analyze and assess production, customer feedback, and returns, and other factors to reduce outages and anticipate future demands. Big data can also be used to improve decision making in the line with current market demands. The seventh one is drive innovation. Big data can help you innovate by studying interdependencies among humans, institutions, entities, and process, and then determining new ways to use those insights. Use data insights to improve decisions about financial and planning considerations. Examine trends and what customers want to deliver new products and services. Implement dynamic pricing. There are endless possibilities. So we have now come to the end of this session. In case you have any questions on what we have discussed today, then please put them in the comment section of the video and we will be really happy answering them. Till we meet next, is best wishes from TNV Academy. Thank you.